Good morning, chemistry students. My name is Mr. Adam. This is chemistry. Today is the 26th of May. It's a Tuesday, and is a day 3 in our rotation. So, good morning, everybody. I hope you had a wonderful, long weekend. We're back in action after a nice 3-day weekend. I talked to some of you before the weekend and got to catch up a little bit, see what you guys were doing. It sounded like a lot of you were getting away, getting a chance to get out of the house and go maybe see family, maybe see some friends in small gatherings. And so I hope you got to get outside a little bit, got to enjoy the weekend, got to maybe catch up and do something a little bit different than the routine that we've been in. And I really hope you got a chance to relax, recuperate, and kind of revive yourself, revive your spirits a little bit. So hopefully you got to spend some time doing something fun, got to eat some hot dogs or burgers or something really good, and got to enjoy yourself this weekend. I hope you're still staying safe and being smart about making decisions on who you spend time with and how to stay healthy, but I hope that you're also worried about your mental health a little bit and trying to enjoy yourself and relax and kind of bring your spirits up. So, hope you had a great weekend and keep staying safe and staying positive. So, we are wrapping up the year really, really soon. It's the end of May. It's the 26th of May, which means June's right around the corner, which means the summer break is almost upon us. So a couple of things. For the end of the year, obviously we still have to finish Unit 2, but then after that I'm trying to decide exactly what we're going to do. So on Friday we'll have our Unit 2 review. We'll have a Kahoot for that, of course, and the practice test online that you can take. And then on Monday we'll take the Unit 2 test. After that we do have a few days where we still have to do content-related things or, actually chemistry-related things. And I'm trying to figure out exactly what we want to do around then because it's kind of up in the air. We can kind of do whatever. We're not going to start a new unit. We're not really going to talk about fire and endothermic and exothermic processes, unfortunately. It makes me a little bit sad, but we don't have time for it. So what we can do is up to you. So on Friday, I talked to a couple of students and asked them, hey, what would you like to do to wrap up the year? How would you like to end the chemistry year? Would you like to do some demonstrations or have me do some demonstrations on camera that you can see? Would you like to watch some chemistry-related YouTube videos? I can find some and we can look at those and discuss those. One student suggested that I do some experiments that you can try at home, either give you a list of them or actually do them on camera and show you them. We could do... What else was I thinking? We could do a round of why does this happen, Mr. Adam? Because you guys would always ask me in class, why does this happen? Why is this way? So we could explain some chemistry phenomena that we see all around us all the time. We can ask questions about science and chemistry that you're curious about. That's what that is. And we could wrap up with some elements trivia or some fun facts about the periodic table and elements. We could wrap up with chemistry jokes. I don't know what you want to do. But whatever you want to do, whatever ideas you have, if you just brainstorm for a little bit about how you want to wrap up the year in chemistry, let me know. Because I have some ideas of what might be fun, but I want to hear from you what you think what might be fun or what you really want to know in your last twilight hours of chemistry, right? So if you have some burning questions, some things you always wondered about, some things you didn't quite understand this year, let me know, and we can cover them in the last few days of chemistry that we have. Okay, so that's kind of it for announcements and general things to talk about. So today's lesson, you're still talking about the overall polarity of molecules and how that relates to smell. Obviously, we're wrapping up soon, so we're trying to bring everything together in this big picture. Everything we've learned about structural formulas, isomers, molecular shape, polarity, and how that all relates to smell. So today, you're trying to figure out whether or not a molecule is overall polar or nonpolar. We're not talking about the individual bonds, right? We know how to tell if an individual bond is polar or nonpolar. We use the electronegativity scale. But if we're talking about a molecule being polar or nonpolar, we need to go through this process. We need to use this quote-unquote flowchart here. And this flowchart is going to tell us, based on how we answer the questions here, whether or not our molecule is polar or nonpolar. Okay? So, anytime you have a molecule, let's say we have this molecule here. Excuse me. Anytime we have a molecule, we have to answer these questions to determine whether the molecule is overall polar in green or nonpolar in orange, okay? So the first question to see if a molecule is polar or nonpolar is, does that molecule have polar bonds? In other words, this carbon to this hydrogen here, is that a polar bond? Is there a difference in electronegativity that's greater than 0.4? Or is one atom significantly stronger than another, therefore making that bond polar, right? So if you look at carbon, carbon is in the 2.6-ish range, I think, and hydrogen is in the 2.1 range. So this bond is polar. The difference between these two is enough that it makes this bond polar, okay? So the first question is, are my bonds polar or nonpolar? Yes, my bonds are polar. Obviously, if my bonds are nonpolar, then my overall molecule is going to be nonpolar, right? If you don't have polar bonds, you're not going to have a polar molecule, okay? All right, my second question is my molecule linear or tetrahedral in shape? Now you have to remember what linear and tetrahedral are, right? Linear is if you have a straight line, so this doesn't look entirely linear, but if you just had this, it would be a straight line, two atoms, like this. And tetrahedral is when you have this kind of like four-way shape here where you have three atoms on the bottom and then one kind of sticking out of the top, right? This is a tetrahedral molecule. So if your molecule is linear or tetrahedral, then it has the potential to be symmetrical, and then those polar bonds can cancel each other out. So this first question is it linear or tetrahedral, and then is it symmetrical? So if it's linear or tetrahedral, yes, this is tetrahedral, then you move on to the next question. If it's not linear or tetrahedral, like this molecule here, then there's no potential for symmetry that cancels everything out, right? This can be symmetrical in a way, but what this is showing is that there are different atoms on this side than there are on this side, right? It is kind of lopsided in a way, so that can't be symmetrical. So if you don't have that linear tetrahedral shape, immediately you know that it is polar if you have polar bonds and it's not linear tetrahedral. All right, last question. Is this molecule symmetrical or not? So if we look at this molecule, is this symmetrical? Is it completely even on all sides? Is it surrounded by the exact same atom on all sides? Yes, right? This carbon in the middle is surrounded by hydrogens that are evenly distributed all the way around. In fact, remember that electron domain theory says that all of these electron domains, all these bonds, want to get equally away from each other. So they have to be symmetrical because they're trying to push each other away the exact same amount, okay? So this is a symmetrical molecule. And because it's symmetrical, all those bonds are tugging outwards. They're kind of contesting each other in a tug of war, and they're all canceling each other out. So even though it has polar bonds, because it's tetrahedral and because it's symmetrical, those bonds all cancel each other out, and that makes them nonpolar. This molecule is nonpolar because it's symmetrical. Okay? If it were not symmetrical, if you had, do some quick surgery here, if you had a molecule on top here that was different than these three other atoms, if you had an atom on top here, sorry. If you had an atom on top here that was different from these three other atoms, then this is not symmetrical. Yes, it's a tetrahedral shape, but there's a different atom up here making this not symmetrical, and because this is more electronegative than all of these, then this bond would be more polar, and this molecule would be polar. So when you're looking at the symmetry on that last step, you're looking to see whether or not the atoms are all the same, if the atoms are all symmetrical. Okay. So that's what you're doing today. We talked a little bit about it in our video on Friday about how overall polarity results from polar bonds and asymmetry, or something being not symmetrical. But yeah, you're using that chart today to determine whether or not molecules are polar or nonpolar overall. So most important thing today, if you have a chance, give me an idea of what you would like to see in our last couple days of chemistry. What would you like to do together that's not necessarily related to molecules and smells, but related to anything in all of chemistry that you'd like to learn about? Let me know in the comments or on Dashboard or on Google Classroom or via email. Let me know what you'd like to wrap the year with. Good luck. This is our last real week of learning something new. I know it's crazy to believe. But good luck this week. If you have any questions, let me know, and I will talk to you all tomorrow. Let's go 1, 2, 3. Clap on me. See you tomorrow.